Hey there, Mr. Weaver here, and this is the Geometry Unit, Lesson 4, Converse of the Pythagorean Theorem. After this lesson, you need to be able to determine if a triangle is a right triangle by using the converse of the Pythagorean Theorem. Let's learn. Converse of the Pythagorean Theorem. So the converse of the Pythagorean Theorem states that if the sides of a triangle have lengths a, b, and c such that a squared plus b squared equals c squared, then that triangle is a right triangle. Essentially, all you're going to do is plug in the sides of a triangle to see if the Pythagorean theorem works. So your two shortest sides would go for a and b, your longest side would go for c. If you find that a squared plus b squared equals c squared, then that means that the Pythagorean theorem works, and if the Pythagorean theorem works, you have a right triangle. So the converse here just is a reverse statement of the Pythagorean theorem. So if you reverse the if and then parts, you have its converse. In the original Pythagorean theorem, it says if a triangle is a right triangle, right? We saw those little like squares in the corner to show that it was a right triangle, then a squared plus b squared equals c squared. The converse is just the reverse of that. If a squared plus b squared equals c squared, so that Pythagorean theorem there, if that's true, then your triangle is a right triangle and not some other form of triangle. So let's look at this with numbers. Consider the triangle with dimensions 3 meters, 4 meters, and 5 meters, as shown. To determine if this triangle is in fact a right triangle, we're going to use the converse of the Pythagorean theorem. So we're going to take those three numbers, plug them into the Pythagorean theorem to see if it's true. So if the Pythagorean theorem is true, then it's a right triangle. So A is 3, B is 4. Those were the two shorter sides. They have to be A and B. It doesn't matter which is which. But C is the long side, 5. Now, let's multiply it out. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. If I add the A square and the B square together, I get 25. Is 25 equal to 25? Yes. So since the Pythagorean theorem was true, then this triangle is a right triangle. So even though they didn't put that little box in the corner, now we can to show that it's a right triangle. Example 1. Use the converse of the Pythagorean theorem. So a carpenter is framing a wall and needs to ensure that the wooden boards form a right angle. Determine whether the triangle shown is a right triangle. So we want to know, is that down here a right angle? So does the Pythagorean theorem work? So our two short side squares must be equal to the long side square. So if I plug in 6, 8, and 10, again, 6 and 8 are the short sides. They have to go for A and B. 10 is the longest side. It has to go for C. Multiplying it out, 6 times 6 is 36. 8 times 8 is 64. 10 times 10 is 100. 36 plus 64, does that equal 100? Yes, it does. So, since these side lengths, when you're plugging them into the Pythagorean theorem, they satisfy that converse, then this triangle is a right triangle. So yes, it is a right triangle. Check your understanding. Read through the situation and use the diagram to determine whether the triangle shown is a right triangle. Pause the video now and complete the check. Check your answer. You should have said, no, this is not a right triangle. So, to figure that out, my two short sides are 12 and 24. Those squares added together must be equal to 27 to the second power. 12 times 12 is 144, plus 24 times 24 is 576. Those two things added together are going to be 720. Does that equal 27 times 27? So 27 times 27 is 729. Are those two things equal to each other? They are not. So this is not a right triangle. It's close, but it is not a right triangle. In order for it to be a right triangle, it has to be exact. Example 2. Use the converse of the Pythagorean theorem. Angela's creating a rectangular patio in her backyard. In order to ensure that the patio space has right-angled corners, she measures the diagonal to create a triangle. Determine whether the triangle shown is a right triangle. So we have dimensions of 13 feet by 20 feet. The diagonal was 25 feet. So is this a right triangle? Does the Pythagorean theorem work? We're going to plug in 13 for A, 20 for B, since those are the short sides, and 25 for C, since that is the longest side. 13 squared is 169, 20 squared, 400, 25 squared is 625. So 400 plus 169 is 569, not 625. So since these particular side lengths did not satisfy the Pythagorean theorem, this is not a right triangle. So not a right triangle. Check your understanding. Read through the situation and use the diagram to determine whether the triangle is a right triangle. Pause the video now and complete the check. Check your answer. You should have said, yes, this is a right triangle. The angle there is a right angle. Based on the picture here, it doesn't look like it, but this is a 3D drawing. So if we did 63 squared plus 60 squared, we would get 87 to the second power. 63 times 63 is 3,969. 60 times 60 is 3,600. And then 87 times 87 is 7,569. If we add these two things together, we do in fact get that same value, 7,569. So, since those are the same, we have a right triangle.